Hello class, today we're going to learn about how to solve rational equations graphically. So in the last lesson we learned how to solve rational equations algebraically. We're going to talk about what it means graphically. So let's do a question together. We're going to consider the rational function of f of x equals 1 over x minus 3 plus 2 and g of x equals x minus 1. So what it means to solve a rational equation graphically means to find the point of intersection between one function which is rational and another function which could be rational, or in this case it's linear. And so this is going to be very important that we have to make sure that we're going to graph things accurately. So in order to do that, we need to understand the properties of this rational functions. So if I look at that rational function, f of x, things I'm going to want to pull out from this equation is things like the vertical asymptote, which if you recall happens because of the denominator here. So therefore we know that it's going to happen at the equation of x equals positive 3. Then we're also going to look at the horizontal asymptote, and that happens again usually at 0 for the parent function, but because it moved up 2 units, therefore the horizontal asymptote is now at y equals 2. And looking at what else we have, there's no dilation, so that means that it's just the parent function shifted to the right 3 and up 2. So I can draw that. So here is the vertical asymptote that happens at x equals 3. And the horizontal that happens at y equals 2. And since there is no dilations, that means the corner points for the rational function should happen 1 up, 1 over from the origin of the asymptotes, and then 1 left, 1 down. So the curvatures will look something like this for the top right, and something like this for the bottom left. All right, and so this is my f of x graph. 1 over x minus 3 plus 2. And then I'm going to draw the g of x function. Why is that not in green? There it is. And it's just a linear. Okay, so if it's a linear function, we go back to the idea of a y-intercept happens at -1. And then the slope, which is just 1, so that means rise or run, it goes up every so often. So the graph looks something like this. And something like this down here. Okay, so there's my g of x equals x minus 1. And so what I'm looking for is the point of intersection between these two graphs. They happen at this point on the functions and this point on the functions. So I can write, therefore, the POIs are at the actual graph. It does not happen at the asymptotes, so they are at 2 and 1 and at 4 and 3. Okay, if we're doing this graphically, to note is that most likely you're going to get, when we do it graphically, you're going to get integers, right? Because that way you could actually determine the points. Okay, so if we're asking you to do them graphically, most likely they're going to happen at good points, and we're not going to ask you to estimate where those points are, like a third or something like that. All right, but let's check and make sure that we graphed it properly and that we actually saw these points of intersection happening at these spots. So we go back to what we learned in the last lesson, which is that if we're asking for when the f of x meets g of x, we're talking about making the two equations equal to each other. So you would have replace f of x with 1 over x minus 3 plus 2, And we're saying that it's going to equal or have the same y value as x minus 1. Right? So that's what they're saying. The y values are equal. So now I'm just going to solve it. Reminder that what we're going to try to do is we're going to try to first make it so that's just one fraction and one fraction. So I'm going to move 2 to the other side. So I got 1 over x minus 3 equals x negative 1 minus 2 will be minus 3. Okay, and what we could do in this case is we're going to bring x minus 3 over. So it becomes 1 equals x minus 3 squared, right? Because I'm multiplying x minus 3 times x minus 3. Well, that allows me to now do the plus and minus the square root of 1, and that equals x minus 3. So now we can either say that we're doing plus or minus 1 is equal to x minus 3. So that means x can therefore be x is equal to 3 plus 1, or x is equal to 3 minus 1, which means it could equal to 4 or could equal to 2. So if I plug that in, if I do that in for my g at x here, which was equal to x minus 1, let's go g at 4 is equal to 4 minus 1, which is at 3, or g at 2 is equal to 2 minus 1, which is equal to 1. So according algebraically, we're also seeing that the POI are for 3 from this one here and 2, 1. So that's the same answer we got above, where we have the same 2 POIs. Great. All right, let's look at another scenario. Let's look at this rational function here. F of x equals 2x minus 1 all over x plus 1. And then our g at x is also another line, which is negative x plus 3. So we now again have to find the point of intersection by graphing them. So if we do that, therefore, we're going to find out that using our understanding of rational functions, we need to find the vertical asymptote, which always happens at the denominator here. So that would mean that x, it happens at x equals negative 1, because it would make this denominator 0. And then the horizontal asymptote, we know, happens when the coefficients of the first two terms here, and that's going to mean that it's 2 divided by 1, so the horizontal asymptote happens at y equals 2, right? Because we have that 2 over 1x there, okay? Or what we used to say, ax over cx. Okay, what other things we need to find from this equation that will help us graph it accurately is the x-intercept, right? And the x-intercepts happen at the numerator of the rational function. So that happens at 2x minus 1, so that when that equals to 0, so it would be 2x is equal to 1, so x equals 1/2. So therefore we know that the x-intercept happens at 1/2, 0. And the y-intercept we know happens at the b over d, so that happens at negative 1 over 1, so therefore it's at the point 0, negative 1. Okay, great. So now we have all the 4 key features from this rational function. In order to graph it accurately, I'm going to draw my vertical asymptote here at x equals negative 1, and my horizontal asymptote at y equals 2. And then I know my x-intercept is at 1/2 and 0. And I can also graph the mirror image of that, right? So to get to that point, I went 1/2 over, 2 down. So I'm going to go 1/2 over, 2 up. There's a mirror image of that one. The y-intercept is at 0, -1, which is here. The mirror, so that was 1 over from the origin of the asymptote, 3 down, so I'll go 1 over, 3 up. So there's the mirror image. Okay, now I can draw my rational function here. I'm going to draw it up here as well. Okay, all right, so that's my f at x graph. And now I need to draw my g at x graph. There's a y-intercept at +3, so 1, 2, 3. And I have a slope of -1 over 1. So that means 1 down, 1 over, so something like this. And then something like this as well. And since we graphed it accurately, I can see my points of intersection happening in this dot here and this dot here, again in integers. So therefore, my POI are at -2 and 1, 2, 3, 4, 5. Ooh, I forgot scale. Don't forget to write scales in your graph, please. So 1, 1. And my other point of intersection, which is 2, 1. Okay. So just make sure, if this one we can tell because we had the mirror image. If you aren't sure if this was actually on the integer, you can always plug it in. So if I know for sure, I know that the g of x happens here at 2, right? Because of the integer slope. So if I'm not sure, I can always check to see if it actually fits into my rational equation. So if I plug in 2 into my rational equation, I'll have 2 times 2 minus 1 all over 2 plus 1. So I have 4 minus 1 over 3. Well, that's 3 over 3, which is equal to 1. So I know that the rational function of f at 2 happens at 2, 1, which is exactly where the green or linear function happened as well. So that I just verified it again quickly to see if it actually met at that point. And it does. So the key idea behind this lesson is that make sure you can graph the rational function accurately. You know how to graph the other function accurately because hopefully from linear components. And if you do that properly, you should be able to find the points of intersection on the graph. So good luck, have fun.